We all know Magneto as the X-Men's master of magnetism. We've seen him do everything from levitating entire stadiums to stopping bullets mid-air and even controlling the iron in blood. But how much of this is actually realistic physics? Could someone with Magneto's powers exist today? How deep do his powers really go? Today, we're doing a deep dive using advanced level physics, breaking down his abilities to see if he's bending metal or bending the laws of reality.
In the Marvel Comics, Eric Lenscher was born with the ability to manipulate magnetic fields due to a genetic mutation. However, his abilities weren't realized yet. As a young Jewish boy in Nazi-occupied Europe, Eric was imprisoned in Auschwitz. This is where his powers first manifested. Under extreme emotional distress, when he was separated from his parents, he bent a metal gate in anger.
Some versions of his story, like in X-Men First Class, suggest he learned about physics and magnetism later. Eric is said to have studied engineering or physics, possibly at a university level, to scientifically enhance his control over electromagnetism, but this obviously depends on the continuity. Given his deep understanding of electromagnetism, it's likely that Magneto either formally studied physics or self-educated himself over time. His knowledge extends beyond just magnetic fields. He understands particle physics, quantum mechanics, and nuclear forces, likely holding a PhD-level understanding of electromagnetism and quantum field theory.
Now that we know how he got his powers and understanding of them, let's explain them. First, let's tackle how Magneto generates magnetic fields. In classical electromagnetism, magnetic fields are created from moving electric charges or changes in electric fields. For Magneto to create magnetic fields from nothing, he would either have to move charges in the environment or manipulate the existing electromagnetic field tensor. Maxwell's equations describe these fundamental laws. Ampere's law with Maxwell's equation gives us the equation.
But what about Magneto's flight? Flying with magnetism is tricky. He could just repel the Earth's magnetic field, but Earth's field is only around 25 to 65 microteslas, nowhere near strong enough to push a human. However, we have seen the levitation of living beings before. In 1997, researchers in the Netherlands successfully levitated a live frog using an extremely strong magnetic field, around 16 teslas, in a high-field magnet.
This was possible because water, which makes up around 75% of a frog's body, is diamagnetic, meaning it is weakly repelled by magnetic fields due to Lenz's law. The physics behind the experiment is described by the condition for magnetic levitation on screen, where the first term is the required gradient of the magnetic field squared. U0 is the permeability of free space, ρ is the density of the material, g is the acceleration due to gravity, and chi is the magnetic susceptibility of the material. For small objects like a frog, the field gradient required was around 1,000 teslas squared per meter, which was achieved using a specially designed magnet.
But Magneto isn't a frog. For Magneto to levitate via the same principle, the size scale L must change to about 1.88 meters for his height. We calculate that the B is roughly equal to 43.4 teslas. Thus, Magneto would need to generate at least 43.4 teslas to levitate himself using this diamagnetic effect. This is nearly the strongest magnetic field ever produced in a lab, being 45.22 teslas, and far beyond Earth's natural magnetic field, 25 to 65 microteslas.
For the levitation of ferromagnetic materials like steel and iron, Magneto would have to balance the electromagnetic and gravitational forces in a similar but different way. Ferromagnetic materials have high magnetic susceptibilities due to the unpaired electrons and the parallel alignment of spins. This also causes the net magnetization vector of these materials to be zero because of the random orientation of domains, as the magnetic moments cancel one another.
Like before, to maintain levitation, the magnetic force equals the gravitational force. However, unlike diamagnets, ferromagnetic materials do not naturally levitate because they are strongly attracted to magnetic fields. We have seen the levitation of ferromagnetic materials before. Maglev trains use electromagnetic suspension, which uses active feedback loops to adjust the magnetic field dynamically, but can Magneto sustainably do this with objects like a large bridge? What output would he need to do this? Let's dive in.
The force on a ferromagnetic object in a magnetic field gradient is given by this equation, where V is the volume of the ferromagnetic material. Since we know B and mu for ferromagnetic materials, we can rewrite the force as so. If we want to calculate the magnetic field Magneto would need to produce for a steel bridge, let's assume it has a volume of 2,000 cubic metres and a total mass of 15.7 million kilograms. This would mean that its weight is equal to 1.5 times 10 to the 8 newtons. When rearranging for B, we find it's 0.31 teslas, assuming an ideal field gradient. This would need a massive power input and strong, very large electromagnets, but from how he was able to levitate himself, this doesn't seem too far-fetched.
However, Earnshaw's theorem states that a static magnetic field cannot stably levitate a ferromagnetic object without additional stabilization. One must use electromagnetic feedback control, magnetic barons, like in EMS, rotating magnetic fields, spin-stabilized systems, that induce eddy currents that create repulsive forces, or superconductors, flux pinning.
Researchers Wang et al. Showed that the ferromagnetic particles can levitate over a superconductor due to flux pinning and magnetic traps. Superconductors expel external fields through the Meissner effect, but small imperfections in the material can trap magnetic flux tubes. When a ferromagnetic object is placed above this material, it gets trapped in a magnetic potential well and levitates. Magneto's version? He could be directly inducing these flux pinning states in normal metals, simulating the effects of a superconductor without needing one. But what if Magneto's powers extend beyond classical electromagnetism?
What if Magneto was a living quantum field manipulator? Considering his background in physics and his deep understanding of his powers, it's not far-fetched to assume he would have knowledge of the quantum world. If Magneto isn't just controlling metal through classical magnetic fields, but is fundamentally manipulating the quantum properties of matter, then we're talking about something far more extreme: quantum electrodynamics, electron spin alignment, and even vacuum fluctuations.
At its core, magnetism isn't just about moving charges, it's about spin. Every electron has an intrinsic angular momentum, or spin s equals half, which contributes to the magnetic moment. If Magneto has control of a spin alignment at the atomic level, he wouldn't just be influencing external fields. He could be directly altering the electronic structure of materials, forcing any substance to exhibit magnetism on demand. That would explain why he can manipulate non-magnetic metals like aluminium, which is paramagnetic, and even materials that normally don't respond to magnetic fields at all.
Huillery et al. Demonstrated that levitated ferromagnetic particles exhibit controlled spin dynamics, which means precise spin control can dictate an object's rotational and translational motion. Simply put, if Magneto can control spin alignment at the quantum level, he doesn't just move metal, he defines how it moves with extreme precision. This would overrule Earnshaw's theorem, as this would explain how he stabilizes ferromagnetic materials, how he can fine-tune their movement without external forces, and why his metal manipulation seems effortless. It's because he's controlling things at the quantum spin level rather than just using brute force magnetic fields.
But what if he's going even deeper, beyond electric spin, down to fundamental quantum fields? In quantum electrodynamics, electromagnetism isn't just a force. It's mediated by the exchange of virtual photons. This means that every magnetic interaction Magneto controls is actually him manipulating the exchange of force carriers in the quantum field. Mathematically, the strength of this interaction is governed by the fine structure constant alpha, which determines how strongly electrons couple to photons.
If Magneto could alter this fundamental constant locally, he could change the way electromagnetic fields behave, essentially rewriting the rules of electromagnetism in a given space. That means his control isn't just about bending or levitating metal, it's about reshaping the very physics governing magnetic interactions.
Empty space isn't actually empty. Thanks to quantum fluctuations, the vacuum is filled with virtual particle-antiparticle pairs constantly appearing and annihilating. This gives rise to zero-point energy, the lowest possible energy state of the universe, described by the energy density equation.
Although these fluctuations are normally imperceptible, strong enough electromagnetic fields can polarize the vacuum itself, altering how virtual particles behave. If Magneto can tap into this, he might be able to generate magnetic fields even in free space, allowing him to manipulate metal objects from vast distances without requiring a pre-existing field. This could also explain why Magneto is sometimes shown blocking energy blasts. If he can alter the vacuum energy density, he could change the propagation of light and other electromagnetic waves around him.
At extremely high energies, above 100 gigaelectron volts, electromagnetism and the weak nuclear force unify into the electro-weak force. This means that in principle, Magneto's power could extend beyond electromagnetism. If he had control over electro-weak interactions, he wouldn't just be manipulating metal, he could be affecting the weak nuclear force itself, altering radioactive decay rates, and even influencing fundamental nuclear processes. This level of control would mean his powers extended to the very fabric of matter itself. At that point, he wouldn't just be a master of magnetism, he'd be manipulating the structure of the universe.
Magneto's powers go far beyond what we see in the comics and films. If he truly has the ability to manipulate magnetic fields at such an advanced level, he could be using physics in ways we can only imagine. From controlling electron spin at the quantum level to potentially altering the fundamental constants of nature, Magneto's abilities stretch across classical electromagnetism and deep into the realm of quantum field theory.
In fact, he might not just be a master of magnetism, but a true manipulator of the fundamental forces of the universe. While his powers are purely fictional, the scientific principles behind them showcase just how amazing and complex the interactions of physics can be.
So, while Magneto might not be a real-world possibility, the science behind his powers is certainly a fascinating exploration into the frontiers of what might one day be possible.